Hello there, gentle wanderer. Thank you for finding your way here tonight, to this quiet corner where we explore the vast mysteries that surround us. I'm deeply grateful you've chosen to spend these moments with me. Tonight, we're going to venture to the very edge of everything we know, and perhaps peek beyond it. We'll explore one of the most wonderfully puzzling questions humans have ever dared to ask. If there's an edge to the universe, what could possibly lie past it? It's a question that has tickled the minds of children and cosmologists alike, one that invites us to stretch our imagination to its very limits. I'm curious, where are you listening from right now? Is it late evening where you are, or perhaps the quiet hours of early morning? Whatever time finds you, I hope you're somewhere comfortable. If you find yourself enjoying these gentle explorations into the mysteries of existence, please consider giving this video a like or subscribing, mindset, but only if it truly resonates with you. Your support helps these calm conversations reach other curious souls wandering through the night. I should warn you though, mind this topic absolutely fascinating, perhaps dangerously so. While I'm here trying to help you drift towards sleep, I might get a bit too excited about cosmic boundaries and infinite possibilities. Please forgive me if my wonder keeps you awake when you'd rather be dreaming. So settle in, let your breathing slow, and let's take a gentle journey to the edge of everything. Think back, if you will, to when you were very small. Perhaps you remember playing in a sandbox, your tiny hands building castles and roads in the sand. But what fascinated you most wasn't the castle itself. It was the edge of the sandbox. It was the edge of the sandbox, that clear wooden border that said, here the sand ends and there the grass begins. Something about that boundary felt important, didn't it? It gave shape to your small world, made it manageable, comprehensible. We humans are creatures who live surrounded by edges. The edge of our bed where we feel safe. The edge of our yard, marked perhaps by a gentle fence or a row of flowers. The edge of our town, where familiar streets give way to unknown highways. Even the edge of our vision, that soft blur at the periphery where the world fades from sharp focus into mystery. These boundaries serve us well. They help us navigate our days, organize our thoughts, and feel secure in our place. When you walk into a room, your eyes automatically seek its edges, the walls, the corners, the doorways. Your mind maps these boundaries without conscious effort, creating a mental picture of the space you inhabit. It's as natural as breathing, this need to understand where things begin and end. But boundaries do more than just organize space. They organize meaning. Consider a painting hanging on your wall, or without its frame. The image might seem to flow endlessly into the wall itself. The frame creates a boundary that says, here is the artwork, complete and contained. Or think of a story. Without once upon a time, and the end, it would be just an endless stream of events, beautiful perhaps, but somehow unsatisfying. Even in nature, we find comfort in edges. The shoreline where ocean meets land gives us a sense of place. We can say, I am here on solid ground, while the vast water is there. Mountain ridges create clear boundaries against the sky. Forest edges mark the transition from open meadow to deep woods. These natural boundaries help us orient ourselves in the world, give us reference points for understanding where we are and where we might go. And perhaps most fundamentally, we ourselves have boundaries. Our skin marks where we end and the rest of the world begins. It's a boundary so basic, so essential, that we rarely think about it consciously. Yet it shapes everything about how we experience existence. The warmth of sunlight on our arms, the cool touch of water, the gentle pressure of a hug. All of these sensations depend on that boundary between self and not self. So when we turn our gaze upward to the night sky, it's only natural that our boundary-seeking minds begin to wonder, where does all of this end? Surely we think even the vast cosmos must have some kind of edge, some ultimate boundary, beyond which, what? The question bubbles up from the same deep place that once made us curious about the edge of that childhood sandbox. But here's where things begin to get wonderfully strange. Because when we start asking about the edge of everything missed in universe itself, we quickly discover that our everyday experience with boundaries might not be the best guide. The cosmos, it seems, plays by different rules than sandboxes and picture frames. It challenges our assumptions about edges and beginnings, and ends in ways that are both humbling and thrilling. Tonight, as we explore this cosmic puzzle together, we'll find ourselves stretching beyond the comfortable boundaries of everyday thinking. We'll venture into ideas that might feel as foreign as trying to imagine a new color, or as disorienting as walking into a room with no walls. But don't worry, we'll take it slowly, gently, one step at a time. There's something deeply comforting about knowing where things end, isn't there? When you pull a blanket up to your chin at night, you're creating a boundary, a cozy edge between your warm, safe space and the cooler world beyond. That boundary brings peace, a sense of being contained and protected. It's no wonder that when we contemplate the universe, our minds instinctively reach for similar comfort, hoping to find some ultimate cosmic blanket edge. But boundaries can also make us uneasy. Have you ever stood at the edge of a tall cliff and felt that strange mixture of fear and fascination? Part of you steps back from the precipice, while another part peers over, drawn by the mystery of what lies beyond. This same duality appears when we think about cosmic edges. We want them to exist because they would make the universe feel manageable, comprehensible. Yet we're also thrilled by the possibility that they might not exist at all. Children often ask the most profound boundary questions without realizing their depth. What's past the end of the world, Mommy?
Oh,
5-year-old might wonder. And suddenly we adults find ourselves grappling with concepts that have puzzled philosophers and scientists for millennia. The child's question cuts straight to the heart of our relationship with infinity and the unknown. We want to give a satisfying answer, but we're forced to confront the possibility that some questions might not have the kind of answers we expect. Our need for boundaries is so strong that we often create them even where none exist naturally. We draw lines on maps to separate countries, though the Earth itself recognizes no such divisions. We mark time zones, creating sharp boundaries where noon becomes 11:59, even though the sun's journey across the sky is perfectly continuous. We invent categories and classifications, creating mental boundaries that help us organize information, but sometimes mask the fluid, interconnected nature of reality. This boundary-making tendency serves us well in most situations. It helps us make decisions, solve problems, and feel oriented in the world. But when we apply this same instinct to the universe as a whole, we might be like someone trying to draw a frame around the ocean. The ocean doesn't need a frame to be complete. It simply is what it is, vast and boundaryless, defining itself through its own existence rather than through any edge. Yet, there's something beautiful about our persistent questioning. Even when faced with concepts that strain our understanding, we keep asking, what's beyond the edge? What came before the beginning? What lies outside the outside? These questions reveal something essentially human, our refusal to accept mystery without at least attempting to probe its depths. Sometimes our discomfort with boundaryless concepts leads us to create provisional boundaries, temporary resting places for our minds. We might say, the universe began with the Big Bang, even while acknowledging that we don't really know what before the Big Bang could possibly mean. We create these conceptual boundaries, not because they're final answers, but because they give us starting points for further exploration. The strangest thing about boundaries is that they often define both sides simultaneously. A shoreline isn't just the edge of the land, it's also the edge of the sea. A fence doesn't just mark where your property ends, it also marks where your neighbor's property begins. It also marks where your neighbor's property begins. So if the universe has an edge, that edge would need to separate universe from what exactly? This is where our everyday experience with boundaries begins to feel inadequate, like trying to use a ruler to measure the weight of a song. Perhaps our relationship with cosmic boundaries says more about us than about the cosmos itself. Our need to understand edges and limits might be a reflection of our own bounded existence. We live in bodies that have clear edges, lifespans that have definite beginnings and ends, thoughts that come and go in discrete moments. Maybe our quest to find the edge of everything is really a quest to understand our own place within the vastness. As we venture deeper into tonight's exploration, we'll discover that the universe might be far stranger and more wonderful than our boundary-seeking minds initially imagined. But that strangeness, that gentle challenge to our assumptions, might be exactly what makes the cosmos so endlessly fascinating. Imagine the first human who climbed high enough to see the horizon curve. Perhaps they stood on a mountain peak or sailed far enough from shore to watch their homeland disappear. In that moment, they discovered something remarkable. Their world had a shape, a boundary they could perceive. The flat, endless expanse of their daily experience was revealed to be something far more elegant and contained, a sphere floating in space. This discovery must have been both thrilling and unsettling. If the Earth had boundaries, edges, beyond which lay the vast unknown theories, then what about everything else? The sun that rose and set each day, the moon that waxed and waned, the scattered jewels of stars, did they too have limits? And if so, what lay beyond those limits? Ancient peoples gazed up at the night sky and saw what looked like a great dome overhead, studded with lights. They imagined crystal spheres carrying the planets in their eternal dance, nested one inside another, like a cosmic Russian doll. This vision was beautiful in its orderliness. Everything had its place, its proper boundary, its role in the grand design. The edge of their universe was that outermost crystal sphere, beyond which lay, well, they weren't quite sure, but at least the boundary was there, solid and reassuring. But as human knowledge grew, these comfortable boundaries began to dissolve. Galileo turned his telescope skyward and discovered that the Milky Way, that soft band of light across the night sky, was actually composed of countless individual stars. Suddenly the universe became vastly larger and more mysterious. Where once there had been a definite dome with a clear edge, now there were depths upon depths of starry space. The boundaries kept retreating as our vision improved. We discovered that our sun was just one star among billions in a galaxy. Then we found that our galaxy was just one among billions of galaxies. Each time we thought we might be approaching some ultimate edge, some final boundary, the cosmos revealed new depths, new distances, new mysteries. It's as if we were explorers in a vast mansion, thinking we had mapped every room, only to discover that each door opens not to another room, but to an entirely new wing of the building. And every wing contains doors to yet more wings, in a progression that seems to have no end. At what point do we stop searching for the final door and begin to wonder if perhaps the mansion itself is infinite? This retreating boundary phenomenon reveals something profound about the nature of discovery. Each answer we find generates new questions. Each boundary we cross reveals new horizons. The edge of knowledge doesn't disappear when we reach it. It simply moves further away, like the horizon that always remains the same distance ahead, no matter how far we travel toward it. So Tausa Billy says, "The is Billy." But there's something deeply human about our persistence in asking the boundary question. Even as we've learned that the universe is far vaster than our ancestors imagined, we still wonder, is there an edge somewhere out there? Some ultimate limit beyond which even space itself ceases to exist? The question has evolved, but it hasn't disappeared. Modern cosmology has given us new tools for approaching this ancient puzzle, but it has also revealed just how strange the question really is. We've learned that space itself can expand, that time itself had a beginning, but the very concepts of edge and beyond might not apply to the universe in the way they apply to earthly objects. Yet we keep asking, and perhaps that's the most beautiful thing of all. The same curiosity that led ancient peoples to climb mountains and sail unknown seas now drives us to build telescopes and particle accelerators, to peer deeper into space and time than any human has ever looked before. We are still boundary seekers, still explorers of edges, still wonderers about what lies beyond the beyond. As we prepare to dive deeper into this cosmic mystery, remember that you are part of this grand human tradition of boundary seeking. Tonight, from wherever you're listening, you're continuing a conversation that began around ancient campfires and will likely continue long after our current understanding seems quaint and primitive. We are all explorers together, peering into the darkness and wondering what wonders it might contain. Picture yourself standing on a beach at sunset, gazing out over the ocean. From where you stand, You can see perhaps 20 or 30 miles to the horizon, where the water seems to meet the sky in a soft, distant line. But you know, of course, that the ocean doesn't actually end there. Beyond that horizon lie thousands more miles of water, distant shores, and islands you'll never see from your current vantage point. The horizon isn't the edge of the ocean. It's simply the edge of what you can observe from where you are. This is one of the most important distinctions we need to understand when we talk about the universe and its possible edges. When scientists speak of the observable universe, they're talking about something very much like your view from that beach. It's not necessarily the entire universe, mine. It's just the part we can see from our particular cosmic shore. The observable universe is a sphere centered on us, extending roughly 46.5 billion light-years in every direction. This might seem confusing at first. If the universe is only about 13.8 billion years old, how can we see things that are 46.5 billion light-years away? The answer lies in the fact that space itself has been expanding all this time. Light that left a distant galaxy billions of years ago has been traveling toward us while space has been stretching, carrying that galaxy ever farther away. Imagine two people walking away from each other on a moving walkway that's also expanding as they walk. The light is like a message one person throws to the other. By the time the message arrives, the thrower is much farther away than when they first sent it. This is why our observable universe has grown to be much larger than you might expect from simple multiplication of the speed of light times the age of the universe. But here's the crucial point. To this observable boundary isn't a physical edge. There's no wall out there, no "do not enter" sign marking the limits of space. It's simply the distance beyond which light hasn't had enough time to reach us since the universe began. It's a horizon created by time and the speed of light, not by any actual boundary in space itself. Beyond this horizon, the universe very likely continues. We can't see what's there because the light from those regions hasn't had time to reach us yet. But there's no reason to think that space simply stops at the edge of our vision. It would be rather like assuming that the Earth ends at the ocean horizon just because that's all you can see from the beach. In fact, many cosmologists believe that the entire universe might be vastly larger than our observable portion, perhaps even infinitely large. We're like inhabitants of a small island who can only see to the next island on a clear day, wondering about the size of the archipelago. Our visible island chain might be part of an infinite ocean dotted with countless islands, most of which remain forever beyond our sight. This distinction between observable and actual is crucial for understanding cosmic boundaries. When we ask what's beyond the edge of the universe, we need to be clear about which universe we mean. If we're talking about the observable universe, then beyond its edge lies simply more universe-Maya galaxies, more stars, more space that we cannot see. The edge of the observable universe is like the edge of a spotlight beam in a vast, dark room. Beyond the light lies more room, not a wall. But if we're asking about the edge of the entire universe, or the totality of everything that exists, then we're asking a much deeper and stranger question. We're asking whether reality itself has boundaries, whether there's such a thing as a place where existence simply stops. This is where our cosmic journey becomes truly mind-bending, because while we can easily imagine more ocean beyond the horizon, it's much harder to imagine what could lie beyond the boundary of existence itself. What could beyond everything possibly mean? As we continue our exploration tonight, we'll keep returning to this distinction. Are we talking about the limits of what we can see, or the limits of what there is? The answer to that question shapes everything about how we approach the cosmic boundary puzzle. Imagine you're sitting by a campfire on a clear night. The firelight creates a warm circle of visibility around you. You can see your friends' faces, the rocks you're sitting on, perhaps the nearby trees. But beyond that circle, the world fades into darkness. You know there's more landscape out there. Mountains, valleys, distant cities. But the limited reach of your firelight creates a horizon beyond which you cannot see. The universe has its own version of this campfire horizon, created not by the limited reach of flames, but by the fundamental speed limit of reality itself, the speed of light. Light is the cosmic messenger that brings us information about distant places, but even light takes time to travel. And in a universe that had a beginning, there simply hasn't been enough time for light from the most distant regions to reach us yet. This cosmic horizon is both elegant and strange, unlike the horizon you see from a mountaintop or an ocean shore, which exists because the Earth curves away beneath you. The cosmic horizon exists because of time itself. Every photon of light that reaches your eyes tonight began its journey at some point in the past. The light from the sun started its trip 8 minutes ago. The light from the nearest star outside our solar system began traveling over 4 years ago, and the most ancient light we can see, the cosmic microwave background radiation, began its journey nearly 14 billion years ago, just a few 100,000 years after the universe began. This creates a remarkable situation. When we look out into space, we're also looking back in time. The farther we peer, the deeper into the past we see. It's as if the universe were a vast museum where the exhibits are arranged not by geography, but by history, with the most ancient artifacts necessarily placed at the greatest distances. But there's a limit to how far back we can see, and therefore a limit to how far out we can observe. Just as you can't see beyond the reach of your campfire's light, we can't see beyond the reach of light that has had time to travel since the universe began. This boundary line, the cosmic horizon, isn't moving away from us at the speed of light as you might expect. Instead, it's expanding more slowly, because as time passes, light from slightly more distant regions finally has enough time to reach us. Think of it like this. Imagine you're in a vast dark library where books are arranged by the year they were written, stretching infinitely far in all directions. You have a flashlight that reveals one additional year's worth of books each year. Every year, you can see slightly deeper into the past, slightly further into the library. But no matter how long you wait, there will always be books too distant, too ancient for your light to have reached yet. The cosmic horizon creates some wonderfully mind-bending effects. For instance, galaxies we observe near the edge of our visible universe appear to us as they were billions of years ago, when they were young and actively forming stars. What they look like now, assuming they still exist, is completely unknown to us. They might have evolved into massive elliptical galaxies, or merged with neighbors, or perhaps even been torn apart by cosmic forces. We're seeing their baby pictures, while they might now be cosmic senior citizens. Even stranger, there are galaxies out there whose light is just beginning its journey toward us right now. Billions of years from now, when our sun has died and the Earth is long gone, their ancient light will finally arrive at our former location, carrying information about today's universe to whoever or whatever might be there to receive it. We are simultaneously the recipients of ancient cosmic messages and the senders of messages to the distant future. This horizon also means that the universe has a kind of built-in privacy. There are regions of space whose existence we can be reasonably confident about, but which remain fundamentally unobservable to us. They lie beyond our cosmic campfire's reach, conducting their own cosmic business in perfect isolation from our view. What wonders they might contain, what stories they might tell, remain locked away behind the horizon of time and light. Here's something that might seem impossible at first. You can be traveling toward a destination that's moving away from you faster than you're approaching it. Imagine running toward a train that's accelerating away from you at a rate greater than your running speed. No matter how fast you run, the train keeps getting farther away. This isn't just a metaphor, it's exactly what's happening to light from the most distant galaxies as it tries to reach us through expanding space. The expansion of the universe adds a layer of beautiful complexity to our horizon puzzle. Space itself is growing, stretching like a balloon being inflated, carrying galaxies along with it. This means that while light from distant galaxies travels toward us, the galaxies themselves are being carried away from us by the expansion of the space between us. It's as if the universe is playing a cosmic game of tug-of-war between light trying to reach us and expansion trying to carry its sources away. Space itself, it's growing, stretching like a balloon being inflated, carrying galaxies along with it. For light from relatively nearby galaxies, the expansion isn't much of a problem. The light travels fast enough to overcome the gentle stretching of space and reach us in reasonable cosmic time. But for galaxies at the very edge of our observable universe, the expansion creates a fascinating race. The light left these galaxies billions of years ago when they were much closer to us. As that light traveled through space, expansion carried the galaxies themselves farther and farther away. By the time their ancient light finally reaches us, those galaxies are now much more distant than they were when the light began its journey. In fact, some of them are now so far away that if they emitted new light today, that light would never reach us. The expansion of space would carry them away faster than the light could travel toward us. We can see their past, but their present and future are forever hidden from us. This creates a strange and poignant situation. There are galaxies whose light we receive tonight, galaxies we can photograph and study and wonder about, but which now exist in a part of the universe that is causally disconnected from us. We can never send them a message, never visit them, never know what became of them. They have passed beyond what cosmologists call our cosmic event horizon, the boundary between the regions of space we can potentially interact with and those we cannot. But expansion affects our horizon in another way too. As space grows, the boundary of our observable universe grows with it. New regions of space that were previously too distant for their light to have reached us gradually come into view. It's as if the cosmic fog was slowly lifting, revealing new vistas that were always there but previously hidden. Every moment, our view of the universe becomes slightly larger, slightly more complete. However, there's a twist to this story. The expansion of the universe appears to be accelerating, driven by something we call dark energy that we don't yet fully understand. This acceleration means that in the far future, our cosmic horizon will actually begin to shrink in an interesting way. While light from currently invisible regions will continue to arrive for billions of years to come, we'll gradually lose the ability to see new light from increasingly distant galaxies as they're carried away by accelerating expansion. In the very distant future, trillions of years from now, observers in our cosmic neighborhood will see a much lonelier universe. Galaxies outside our local cluster will have been carried so far away by expansion that they'll disappear from view entirely. Future astronomers will look out and see only the galaxies gravitationally bound to our own, surrounded by an apparently empty universe. They might conclude they live in a small, isolated cosmos, never knowing about the vast cosmic community that once filled their skies. This expansion also complicates any notion of the universe having a simple edge. If space itself is growing, then any boundary would presumably be growing too. But expanding into what? The question becomes not just what's beyond the edge, but what's beyond the edge as it moves outward. It's like asking what's beyond the surface of a balloon as it inflates, and the analogy itself begins to strain under the weight of the concepts we're trying to understand. Picture the most distant thing you can see on a clear night. Perhaps it's a star twinkling in the darkness, or maybe the soft glow of the Milky Way stretching across the sky. But even the most distant stars visible to your naked eye are cosmic neighbors compared to the most ancient light that surrounds us constantly. This radiation is called the cosmic microwave background, and it represents the farthest shore of our cosmic ocean, the most distant lighthouse, whose beam can still reach us across the vast expanse of space and time. It's light that began its journey toward us nearly 14 billion years ago, when the universe was only about 380,000 years old, barely an infant in cosmic terms. To understand this furthest boundary, imagine the universe in its early days as a vast, hot, dense fog. In those first few 100,000 years after the Big Bang, space was filled with a plasma so hot and dense that light couldn't travel more than a tiny distance before being absorbed and re-emitted by free electrons. It was as if the entire universe were shrouded in a glowing, impenetrable mist. Photons of light would try to travel, but they'd immediately bump into electrons and get knocked around, making no progress toward anywhere in particular. But as the universe expanded and cooled, something magical happened. The temperature dropped just enough for electrons to settle down and join with protons to form the first neutral hydrogen atoms. Suddenly, the cosmic fog lifted. For the first time in the universe's history, light could travel freely across vast distances without being absorbed. This moment, called recombination, was like the sunrise after the longest night. The universe became transparent. The light that was released at this moment, the cosmic microwave background, has been traveling through space ever since, carrying with it a baby picture of the entire universe. When we detect this radiation today, we're seeing an image of the cosmos as it was when it first became transparent, nearly 14 billion years ago. It's the oldest light in the universe, and therefore the most distant thing we can possibly observe. This ancient light doesn't look like much to our eyes. It's been stretched by the expansion of the universe from visible light into microwaves, invisible to us without special instruments. But to radio telescopes, the cosmic microwave background appears as a gentle glow coming from every direction in the sky. It's remarkably uniform, but with tiny variations in temperature, hot spots and cold spots that represent the seeds from which all galaxies and stars would eventually grow. These temperature variations are like cosmic fingerprints, telling us about the conditions in the early universe with extraordinary precision. The hot spots were regions that were slightly denser, that would eventually collapse under their own gravity to form the first stars and galaxies. The cold spots were regions that were slightly less dense, that would become the cosmic voids between galaxy clusters. In this ancient light, we can read the blueprint for everything that would come after. What makes the cosmic microwave background so special as a boundary is that it represents a fundamental limit to how far back in time we can see using light. Before recombination, the universe was opaque light. No light from those earlier times can reach us directly. It's as if we're looking at a distant mountain range shrouded in clouds. We can see the clouds clearly, but we cannot see the mountains themselves behind them. This creates our ultimate observational horizon, not because space ends there, but because transparency begins there. Beyond this gentle boundary lies not nothingness, but rather the hidden early history of the universe itself. There are almost certainly galaxies and stars, and perhaps even planets existing at distances greater than we can observe, but their light cannot reach us, because it would have to pass through that ancient opaque fog. Standing on this cosmic shore, looking out at the cosmic microwave background, we're like explorers who have reached the edge of a vast ocean. We can see the distant horizon where the water meets the sky, but we cannot see beyond it to whatever shores might lie on the other side. The difference is that our cosmic ocean has depths in time as well as space, and its furthest shore is also its oldest memory. There's something gentle about the way the universe hides its deepest secrets from us. Unlike a brick wall that stops you with sudden jarring finality, the boundary of our observable universe is more like walking into a softly thickening fog. The farther you peer, the hazier things become, until eventually the details fade into a uniform, glowing mystery. This isn't an accident or a failure of our instruments. It's built into the very fabric of reality. As we look deeper into space and further back in time, we're not just seeing more distant objects. We're seeing them as they were when the universe itself was younger, smaller, and very different from the cosmos we know today. The galaxies at the edge of our vision are cosmic teenagers, caught in the act of formation, their light stretched and reddened by billions of years of cosmic expansion. Imagine watching a movie of the universe's history, but played in reverse as you look farther away. Nearby, you see mature galaxies, like our own Milky Way, full of older, settled stars and well-established spiral arms. Look a bit farther, and you see galaxies that are more chaotic, still in the process of forming their characteristic shapes. Peer even deeper, and you find galaxies that are smaller, bluer, and more actively forming new stars, minus cosmic youngsters, caught in their energetic youth. But as you continue this journey backwards through time and outward through space, the individual galaxies begin to fade and blur. You're approaching the era before galaxies existed at all, when the universe was filled instead with the first generation of massive stars, giants that lived fast and died young. seeding space with the heavy elements that would later form planets, and eventually us. These first stars are tremendously difficult to see, not just because they're so distant, but because they lived such brief lives. They were cosmic phoenixes, burning brilliantly for just a few million years before exploding as supernovas. By the time their light reaches us, stretched and weakened by the expansion of space, it's barely a whisper against the cosmic background radiation. In theory, and beyond even these first stars, lies something even more elusive, the so-called dark ages of the universe. This was a time when the cosmos had cooled enough for atoms to form, but before the first stars had ignited to light up the darkness, just toving before, Konsa, to Dadarisati. During this period, the universe was filled with neutral hydrogen gas, but no sources of light existed to illuminate it. It was a cosmos in waiting, pregnant with possibility, but not yet awakened to its luminous potential. The beauty of this fading boundary is that it's not really an edge at all. Myonix, it's a transition. There's no point where you can say here the universe ends and something else begins. Instead, there's a gradual shift from the observable to the unobservable, from the knowable to the mysterious. It's like the way day fades into night. There's no exact moment when day stops and night begins, just a gentle transition through twilight. This gradual fade creates one of the most poignant aspects of cosmology. We can calculate with great precision how far away the cosmic microwave background is, and we can measure its properties with extraordinary accuracy. But we cannot see beyond it. We know with high confidence that the universe continues past this boundary. There's no reason to think that space simply stops where our vision fails. But what lies beyond remains fundamentally hidden from us. It's rather like being a fish in the depths of the ocean, looking upward toward the surface. You can see the water around you clearly, and you can detect the gentle glow of sunlight filtering down from above. You might even be able to measure the properties of that light and deduce something about the world beyond the surface. But you cannot see the sky itself, or the clouds, or the birds flying overhead. There's a boundary to your perception that has nothing to do with the limits of the world and everything to do with the nature of your environment. In our case, that environment is space-time itself, with its built-in speed limits and its history of opacity in the early universe. We're not looking at the edge of existence. We're looking at the edge of transparency, the boundary beyond which the universe's own structure prevents us from seeing further. Imagine you're standing in a vast dark field at night, holding a lantern. The light creates a circle of visibility around you. Inside this circle, you can see clearly, but beyond it lies darkness. Now imagine that your lantern grows steadily brighter with each passing moment, slowly expanding the boundary of what you can see. Each second reveals new patches of ground, new details of the landscape that were always there, but previously hidden in the shadows. This is remarkably similar to what's happening with our view of the universe. Our cosmic lantern, the sphere of space from which light has had time to reach us. Neos grows larger every moment. As time passes, light from slightly more distant regions finally completes its long journey to Earth, gradually expanding the boundaries of our observable universe. But this growth happens in a way that might surprise you. The edge of our observable universe isn't racing outward at the speed of light, as you might expect. Instead, it expands much more slowly, at about 1 light-year per year. This is because, while new light is always arriving from farther away, the sources of that light were closer to us when they emitted it than they are now. The expansion of space has carried them away, while their light traveled toward us. Think of it like this. Imagine a friend walking away from you while throwing you a ball. By the time you catch the ball, your friend is farther away than they were when they threw it. Similarly, by the time light from a distant galaxy reaches us, that galaxy has been carried to an even greater distance by cosmic expansion. The boundary of our observable universe marks not where galaxies are now, but rather the distance that light emitted from their past locations has had time to travel. This creates a strange and wonderful situation. Every night when you look up at the stars, you're seeing new ancient light for the first time. Holtons that began their journey billions of years ago are arriving at Earth tonight, carrying messages from the distant past. In a very real sense, The universe is still revealing itself to us, still unfolding its history moment by moment. The cosmic microwave background itself is part of this ongoing revelation. The radiation we detect today left its source 13.8 billion years ago. But there's more of this radiation still on its way to us. Right now, there are photons of cosmic microwave background radiation traveling through space that will arrive on Earth tomorrow, or next year, or in 1,000 years. They carry the same ancient message about the universe's infancy, but they're coming from slightly more distant regions of space. This means our map of the cosmic microwave background is constantly being updated with new data from previously unobservable regions. It's as if we're slowly assembling a jigsaw puzzle, where new pieces keep arriving in the mail, each one revealing a bit more of the picture we've been trying to complete. But there's a bittersweet aspect to this expanding awareness. While we're constantly gaining the ability to see new regions of space, we're also gradually losing contact with others. The acceleration of cosmic expansion means that galaxies at the very edge of our current observable universe are being carried away from us so quickly that any light they emit now will never reach us. We can see their ancient light, but their present and future remain forever hidden. In the far future, this cosmic horizon will actually begin to shrink in terms of new information. Billions of years from now, the most distant galaxies will have faded from view entirely, carried away by accelerating expansion. Future astronomers will inherit a smaller, lonelier-looking universe, having lost the ability to see the vast cosmic web that fills our current skies. For now, though, we exist in a special time when the universe is still revealing its secrets to us. Every moment brings new ancient light, new glimpses of cosmic history, new pieces of the puzzle that might help us understand not just what the universe contains, but what it means for something to exist at all. Tonight, as you rest and perhaps drift towards sleep, remember that you are surrounded by this growing bubble of cosmic awareness, this expanding sphere of ancient light that connects you to the deepest history of everything that is. Close your eyes for a moment and imagine you're an ant living on the surface of a perfectly smooth sphere. For now, perhaps a giant marble floating in space. As you walk in what feels like a straight line, you don't realize that you're actually tracing a curved path along the sphere's surface. Or neither. Close your eyes for a moment and imagine you're an ant living on the surface of a perfectly smooth sphere. If you keep walking long enough in the same direction, something wonderful and strange will happen. You'll eventually return to your starting point, even though you never turned around. You've discovered that your seemingly infinite world actually has no edges, yet it's still finite in size. Now imagine instead that you're an ant on an infinite, perfectly flat table. No matter how far you walk in any direction, you'll never return to where you started. Your world truly is infinite. It goes on forever, in all directions, with no boundaries and no edges to bump up against. Hall. Finally, picture yourself as an ant on the surface of a saddle, the curved seat of a horse's saddle that dips down in one direction and curves up in another. In this strange world, if you and a friend start walking parallel to each other, you'll gradually find yourselves moving farther apart, even though you're both trying to walk in straight lines. The very geometry of your world pulls you away from each other. These three scenarios, the sphere, the flat table, and the saddle, represent the only three possible shapes that space itself can have on the largest scales. It might seem impossible that something as fundamental as space could have a shape at all. After all, isn't space just emptiness? But Einstein's theory of general relativity revealed that space itself is something minus a fabric that can be stretched, compressed, and curved by the presence of matter and energy. The spherical universe is called closed or positively curved. In such a universe, space curves back on itself like the surface of a ball. If you could travel far enough in any direction, you would eventually return to your starting point. This kind of universe is finite in size, but has no boundaries, just as the surface of a sphere has a definite area, but no edge where it ends. The flat universe is called Euclidean, because it follows the familiar geometry you learned in school. Parallel lines never meet. The angles of a triangle always add up to 180 degrees, and the circumference of a circle is always pi times its diameter. In a flat universe, space extends infinitely in all directions, never curving back on itself. The saddle-shaped universe is called open or negatively curved. In this geometry, space curves away from itself, like the surface of a saddle or a Pringles chip. Parallel lines gradually diverge. Triangles have angles that add up to less than 180 degrees. And, like the flat universe, it extends infinitely in all directions. What determines which geometry our universe has? The answer lies in its density, En, how much matter and energy it contains. If the universe has exactly the right amount of matter and energy, space will be perfectly flat. If it has more than this critical amount, gravity will cause space to curve back on itself, creating a closed universe. If it has less than the critical amount, space will curve the other way, creating an open universe. Think of it like this. Imagine rolling a ball across a surface. On a flat surface, the ball will roll in a straight line forever. On a curved surface like a sphere, the ball's path will eventually curve back toward its starting point. On a saddle-shaped surface, the ball's path will curve away from where it would have gone on a flat surface. These different geometries have profound implications for the question of cosmic boundaries. A closed universe would be finite in size, and thus wouldn't have an edge in the sense we usually think about. You could travel in any direction forever without ever reaching a boundary, but you'd eventually come back to where you started. An open or flat universe, on the other hand, would likely be infinite in size, meaning there would be no edges because space itself goes on forever in all directions. The remarkable thing is that we can actually measure which geometry our universe has by carefully observing the cosmic microwave background radiation and the way light travels across cosmic distances. And the answer we've found is both elegant and mysterious. The shape of space itself holds the key to one of the most fundamental questions we can ask. Does the universe have an edge? It's a bit like asking whether the surface you're standing on has a boundary. The answer depends entirely on what kind of surface it is. And just as the surface of the Earth has no edge, despite being finite in size, the universe's geometry determines whether it can have boundaries and what those boundaries might mean. Let's return to our ant walking on different surfaces, but this time, let's think more carefully about what edge means in each scenario. On the infinite flat table, our ant could walk forever in any direction without ever reaching a boundary. There's no edge because the surface simply continues infinitely in all directions. If you ask, what's beyond the edge of this table? The answer is simple. There is no edge, so the question doesn't make sense. On the surface of the sphere, something fascinating happens. The ant can still walk forever without hitting a boundary, but now the surface is finite in size. Every point on the sphere is exactly like every other point. There's no special edge location, no place where the surface suddenly stops. If you ask, what's beyond the edge of this sphere, you're asking a subtly different question. You're asking what lies outside the sphere in the third dimension that the ant can't access. But here's where the analogy becomes both helpful and limiting. We can visualize what's outside a sphere because we can step back and see it embedded in three-dimensional space. But when we're talking about the universe itself, we're talking about all of space, not just a surface within space. If the universe is closed like a sphere, there might not be any outside for it to be embedded in. This is where the geometry of space leads us into some beautifully mind-bending territory. In a closed universe, space curves back on itself in a way that's mathematically similar to how the surface of a sphere curves back on itself. But unlike the sphere surface, which curves through a third dimension we can visualize, space curves through dimensions we can't easily picture. The universe might be finite, yet boundaryless, complete in itself, without needing any external space to exist within. The saddle-shaped, open universe presents yet another scenario. Like the flat universe, it extends infinitely in all directions, but its negative curvature creates some strange properties. In such a universe, if you and a friend started at the same point and walked in slightly different directions, you would find yourselves growing farther apart much faster than you would in flat space. The geometry itself pushes everything away from everything else more aggressively than expansion alone would suggest. What makes this discussion more than just mathematical philosophy is that these different geometries lead to different observable consequences. In a closed universe, light traveling in what seems like a straight line would eventually curve back on itself. If you could wait long enough and had a powerful enough telescope, you might theoretically be able to see the back of your own head. Light from Earth could travel all the way around the curved universe and return to its starting point. In an open or flat universe, light travels in truly straight lines across infinite distances. There's no cosmic recycling of photons, no chance of seeing the same galaxy from multiple directions as light takes different paths around a curved cosmos. The critical realization is that the question "what's beyond the edge" depends crucially on which geometry describes our universe. In a flat or open universe, the question might not have an answer because there is no edge and space simply continues forever. In a closed universe, the question transforms into something different, not what's beyond the edge, but rather, what does it mean for space to be complete in itself? Imagine trying to explain the concept of north of the North Pole to someone. The question seems meaningful until you realize that north becomes undefined at the North Pole itself. Similarly, beyond the universe might be a question that seems meaningful until we understand the geometry of space well enough to realize that the question itself might be based on incorrect assumptions about how reality is structured. The geometry of space doesn't just tell us about the universe's possible boundaries, it tells us about the very nature of existence itself. After decades of careful observation and measurement, astronomers have arrived at a remarkable conclusion. Our universe appears to be extraordinarily flat. Not flat, like a pancake minus. That would be thinking in the wrong dimensions, but flat in the sense that the geometry of space itself follows the familiar rules of Euclidean geometry that you learned in school. Parallel lines remain parallel forever. Triangles have angles that sum to exactly 180 degrees, and the shortest distance between 2 points is a straight line. This discovery is far more surprising than it might initially seem. When Einstein first proposed that space could be curved, and when cosmologists began seriously considering the different possible geometries of the universe, flatness was just one option among three. There was no particular reason to expect the universe to be flat rather than curved in one direction or another. In fact, there were good reasons to expect it not to be flat. Here's why flatness is so remarkable. It requires the universe to have almost exactly the critical density of matter and energy, not a little more, not a little less, but just the right amount to balance perfectly on the knife's edge between closure and infinite expansion. It's a bit like balancing a pencil on its point, theoretically possible, but requiring such precise conditions that you wouldn't expect it to happen by accident. To understand just how precise this balance must be, imagine the universe shortly after the Big Bang. If it had contained just a tiny bit more matter and energy than the critical amount, gravity would have quickly curved space into a closed geometry, and the universe would have collapsed back on itself long before stars and galaxies could form. If it had contained just a tiny bit less, space would have curved the other way, and expansion would have proceeded so rapidly that matter could never have clumped together to form the cosmic structures we see today. Yet here we are, in a universe that appears to be flat to within less than 1% accuracy, based on our best measurements. It's as if someone carefully tuned the cosmic parameters to create a universe that would last long enough for complexity to emerge, for stars to shine, for planets to form, and for curious beings like us to evolve and wonder about the nature of existence. This fine-tuning puzzle led cosmologists to propose the theory of cosmic inflation, the idea that the very early universe underwent a period of exponential expansion that stretched any initial curvature nearly flat, like inflating a balloon, until a small patch of its surface appears perfectly flat to someone standing on it. This inflation would have taken any curvature that space might have had originally and stretched it out so much that the observable universe appears flat, even if the larger cosmos might still be curved on scales far beyond what we can see. The flatness of our universe has profound implications for the boundary question. If space is truly flat and extends infinitely in all directions, then the universe has no edge in the conventional sense. You could travel forever in any direction and never reach a boundary, never find a place where space simply stops. The universe wouldn't fade away at the edges or be surrounded by nothingness. It would simply continue, filled with galaxies and stars and planets, possibly forever. But there's a beautiful subtlety here. Even in a flat, infinite universe, we still have our observational horizon, the boundary of what we can see. This horizon exists not because space ends there, but because light from beyond it hasn't had time to reach us yet. It's the difference between the edge of existence and the edge of visibility. Think of standing in an infinite field of flowers under a cloudy sky. Even though the field extends forever in all directions, your vision has limits. You can only see to the horizon created by the curvature of the Earth or the limits of atmospheric clarity. The boundary of what you can see doesn't mark the edge of the flower field. It marks the edge of your ability to perceive it. Our flat universe, if it truly extends infinitely, contains infinite wonders that we will never see, infinite galaxies whose light will never reach us, infinite stories playing out in regions of space that remain forever beyond our cosmic horizon. We live in a finite bubble of observability within what might be an infinite cosmos, a small, illuminated region within an endlessly vast and dark ocean of existence. Try, for just a moment, to imagine infinity. Not the mathematical symbol word that you might remember from school, but the actual concept it represents, something that goes on forever, without end, without boundary, without any possibility of reaching a final point. It's one of those ideas that seems simple until you really try to wrap your mind around it, and then it becomes beautifully, dizzyingly overwhelming. When we talk about an infinite universe, we're asking you to imagine space that never stops. Pick any direction near it, up, down, north, south, toward any star you can see in the night sky, and imagine traveling in that direction forever. In an infinite universe, you would never reach a wall, never find at the end, sign, never arrive at a place where someone had forgotten to put any more space. The cosmos would simply continue, filled with galaxies and stars and planets, perhaps forever. But infinity is stranger than simple endlessness. In an infinite universe filled with matter, the implications become wonderfully mind-bending. Consider this. If space goes on forever, and if matter is distributed throughout that space with roughly the same density we observe in our local cosmic neighborhood, then everything that can happen will happen, not just once, but infinitely, many times. This isn't science fiction. It's a logical consequence of infinity combined with the finite number of ways that matter can be arranged. Think of it like this. There are only so many ways you can arrange, say, 1 trillion atoms. It's a very large number, but it's still finite. It's a very large number, but it's still finite. It's a very large number, but it's still finite. It's a very large number. Now, if you have infinite space filled with matter, you'll have infinite opportunities for those arrangements to occur. Statistically, every possible arrangement must happen somewhere, and in fact must happen infinitely many times. What does this mean in practical terms? It means that somewhere in an infinite universe, there's another galaxy very much like our Milky Way, with a star very much like our Sun, orbiting a planet very much like Earth. And on that planet, there might be someone very much like you, reading something very much like these words, having thoughts very much like the ones you're having right now. In fact, in a truly infinite universe, there would be infinitely many such planets, with infinitely many versions of you, experiencing infinitely many slight variations of this moment. There would be versions where you're reading this under a different lamp, versions where you chose different words to think in response, versions where you fell asleep 3 sentences ago. The infinite cosmos would contain every possible variation of your life, playing out simultaneously across unimaginably vast distances. This might sound overwhelming or even frightening, but there's something oddly comforting about it too. It suggests that every path not taken in your life is taken somewhere else. Every word you wished you'd said is being said by another version of you. Every dream you've ever had is being lived out in some distant corner of forever. But infinite repetition isn't the only strange consequence of cosmic infinity. An infinite universe would also contain things that have never happened in our observable cosmos, stellar arrangements we've never seen, types of planets that don't exist in our galactic neighborhood, perhaps even forms of matter and energy that follow physical laws we haven't discovered yet. Imagine regions of space where the random processes that govern cosmic evolution happen to create perfectly spiral galaxies with mathematical precision, or zones where the accidents of planetary formation produced worlds covered entirely in crystal formations, swing like bells when cosmic winds blow across them. In infinity, even the most improbable arrangements become not just possible, but inevitable. The humbling thing about infinity is that it makes our entire observable universe, vast as it seems to us, into essentially nothing. All the galaxies we can see, all the stars we've ever studied, all the cosmic phenomena we've discovered would represent an infinitesimally small fraction of what exists. We would be like a single drop of water trying to understand an infinite ocean. Yet there's beauty in this cosmic humility. It suggests that no matter how much we learn, no matter how far our understanding extends, there will always be more mysteries waiting, more wonders to discover, more questions to ask. Infinity ensures that the universe will never become boring, never be completely understood, never lose its capacity to surprise and amaze us. Here's a thought that might keep you awake tonight, though I promise it's meant to be soothing. If the universe is truly infinite, then somewhere out there, perhaps unimaginably far away, there's another you reading these exact words. Not someone similar to you, but someone so identical that even their thoughts match yours perfectly at this moment. They're lying in the same position, breathing at the same rhythm, wondering the same things about infinity and cosmic boundaries. This isn't mysticism or wishful thinking. It's a straightforward consequence of mathematics and probability in an infinite cosmos. The idea works like this. You, sitting where you are right now, represent a particular arrangement of atoms. There are roughly 7 quat 10, circumflex 27 atoms in your body, each occupying a specific position and moving in a specific way. That's an enormous number, but it's still finite. There are only so many ways those atoms can be arranged to create you. Now, if space goes on forever and is filled with matter at roughly the same density we observe locally, then somewhere in that infinity, the same atomic arrangement that creates you must occur again. The laws of probability demand it. It's like having infinitely many dice rolls. Eventually, every possible combination must come up, and in fact, must come up infinitely many times. But the strangeness goes deeper than just duplicate bodies. If your atomic duplicate exists, they would necessarily have the same brain structure as you, which means they would have the same memories, the same personality, the same thoughts. From their perspective, they would be you, mine, the original you, mine, just as much as you feel you are the original from your perspective. They would have no awareness of being a copy because they would remember living your entire life, just as you do. Cosmologists have even calculated rough estimates of how far away your nearest identical copy might be. The number is so large, it's difficult to comprehend. Hold something like 10 to the power of 10, circumflex 28 meters away. That's incomparably farther than the edge of our observable universe. To put it in perspective, if you wrote out this distance in normal notation, the number would have more digits than there are atoms in the observable universe. But identical copies are just the beginning. In an infinite universe, there would also be near copies of you, mither versions, that are almost identical, but with tiny differences. Maybe one of them sneezed 5 minutes ago while you didn't. Maybe another chose tea instead of coffee this morning. The infinite cosmos would contain every possible variation of your life, playing out every decision you didn't make, exploring every path you didn't take. There would be a version of you who became an astronaut, another who moved to a different city, one who learned to play piano, one who never learned to read. More dramatically, there would be versions where historical events unfolded differently, where dinosaurs never went extinct, where humans evolved differently, where the laws of physics permit different kinds of chemistry and biology. This infinite branching of possibilities extends beyond individual lives to entire civilizations. Somewhere, there might be an Earth where ancient Rome never fell, where the Library of Alexandria was never destroyed, where different scientific discoveries were made in different orders. There might be versions of human civilization that avoided wars, solved climate change centuries ago, or developed technologies we can't imagine. The philosophical implications are staggering. If every possible version of events plays out somewhere in infinity, what makes any particular version special? What makes your experiences uniquely yours, rather than just one arbitrary sample from an infinite collection of possibilities? Yet perhaps there's comfort in this cosmic democracy of existence. It suggests that every kindness you've ever shown has infinite echoes across the cosmos. Every moment of joy you've experienced is being experienced again and again in countless distant places. Your love for the people in your life, your wonder at a beautiful sunset, your curiosity about the universe itself, all of these are being felt and lived and cherished by infinite other versions of consciousness throughout the endless expanse of space. Some find this idea disturbing, but consider it from another angle. Infinity ensures that every good thing that has ever happened will happen again. Every beautiful moment will be repeated. Every act of love and creativity and discovery will echo endlessly through the cosmos. In an infinite universe, nothing beautiful is ever truly lost, because infinity has room for everything, forever. There's something almost elegantly simple about how infinity resolves our cosmic boundary puzzle. When someone asks, "What's beyond the edge of the universe?" infinity responds with the mathematical equivalent of a gentle shrug. There is no edge, so there's no beyond to worry about. It's like asking, "What's north of north?" or "What comes after forever?" Questions that dissolve when you understand the concepts they're trying to address. In an infinite universe, the notion of an edge becomes not just unnecessary, but actually meaningless. Edges exist to separate one thing from another. The edge of a table separates the table from the air around it. The edge of a forest separates trees from open meadow. But if the universe is everything that exists, and if it extends infinitely in all directions, then there's nothing for it to have an edge against. There's no outside for it to be distinguished from. This might seem like a cop-out, a way of avoiding a difficult question rather than answering it, but it's actually a profound insight into the nature of existence itself. That edge question assumes that the universe is like an object sitting in some larger space, a cosmic island in an even more cosmic ocean. Infinity suggests that this assumption might be fundamentally wrong, that the universe isn't an object at all, but rather the totality of space itself. Think of it this way. Imagine you're a character living inside a novel. You might wonder about the edges of your fictional world, what lies beyond the last page of the book. But the question reveals a misunderstanding about the nature of fictional existence. The novel doesn't exist inside some larger book space that contains it. The novel is complete in itself, and its fictional universe is coextensive with the story itself. Similarly, if our universe is infinite, it doesn't exist inside some larger metaspace. It simply is all of space, extending without limit in every direction. The question of what lies beyond, it becomes as meaningless as asking what's beyond existence itself. But infinity sidesteps the edge question in an even more subtle way. Even if you could somehow imagine traveling to the edge of an infinite universe, which is already a logical impossibility, you would discover that no matter how far you traveled, you would never get any closer to such an edge. In infinity, every point is equally far from any boundary, because no boundary exists. It's like trying to walk to the horizon. No matter how far you walk, the horizon remains the same distance away because it's not a place but a perspective. Similarly, in an infinite universe, any hypothetical edge would always remain infinitely far away, no matter where you started or which direction you traveled. This creates a beautiful symmetry. In an infinite cosmos, every location is equally central, equally far from any edge, equally valid as a reference point for understanding the whole. Earth isn't special because it's at the center of the universe, and as there is no center in infinity. But by the same token, Earth isn't insignificant because it's far from the center as every point in infinity is equally valid as a cosmic address. Infinity also sidesteps temporal versions of the edge. Question. Just as an infinite universe has no spatial boundaries, it might have no temporal boundaries either. If time extends infinitely into the past and future, then questions about what came before the beginning or what happens after the end become as meaningless as questions about spatial edges. This doesn't mean that infinity answers all of our cosmic questions. It just transforms them into different, perhaps deeper questions. Instead of asking what lies beyond the edge, we might ask, what does it mean for something to be infinite? How can we understand our place in a cosmos that has no center and no boundaries? What is the relationship between the finite span of our lives and the infinite context in which they unfold? These questions might not have neat, tidy answers, but they point toward a kind of cosmic wisdom. Who in infinity teaches us that some mysteries might not be meant to be solved, but rather to be contemplated, not to be conquered, but to be appreciated. In an infinite universe, the appropriate response to mystery isn't always explanation, but sometimes simply wonder. And perhaps that's exactly as it should be. Our cosmos, small enough for us to fully understand, might be a cosmos too small to inspire the kind of awe and curiosity that makes us most deeply human. Imagine, if you will, a warm bath on a quiet evening. As you relax in the soothing water, you notice something delightful, tiny soap bubbles forming and floating on the surface. Tiny soap bubbles forming and floating on the surface. Each bubble is a complete little world unto itself, with its own curved surface, its own interior space, its own brief but perfect existence. Some bubbles are large, some small, some last for minutes, others pop almost immediately. Each one is separate from the others, yet all emerge from the same underlying bath water. Now imagine that this bath extends infinitely in all directions, an endless cosmic bathtub filled with warm, soapy water. In such an infinite bath, bubbles would be forming constantly, everywhere, forever. Some regions might have dense clusters of bubbles. Others might have vast empty spaces between scattered solitary bubbles. And each bubble, no matter how small or brief, would contain its own complete little universe of curved space and trapped air. This image captures something profound about one of the most mind-expanding ideas in modern cosmology, the multiverse. What if our entire universe, everything we can see, everything we've ever known, all the galaxies and stars and planets that make up our cosmic home, is just one bubble among countless others in an infinite cosmic bath? The multiverse hypothesis suggests that what we call the universe might be just one of many universes, each with its own space, its own time, perhaps even its own physical laws. These universes might be completely separate from each other, like bubbles that never touch, or they might occasionally interact in ways we can barely imagine. This idea didn't emerge from science fiction or philosophical speculation, though it sounds like it could have. It grew naturally out of our best theories about how the cosmos works. When physicists and cosmologists tried to understand the very early moments after the Big Bang, they discovered that the same processes that could explain the structure of our universe might also create multiple universes. The theory of cosmic inflation, which explains why our universe appears so flat and uniform, suggests that space can expand exponentially under certain conditions. But if inflation happened once, it might happen many times, in many places. Each inflationary event could create its own bubble of expanding spacetime, its own universe, with its own Big Bang, its own cosmic evolution, its own eventual fate. Picture this cosmic process like kernels of popcorn in an infinite pot. Each kernel pops at its own time, creating its own little expansion of fluffy space. But unlike popcorn, these cosmic kernels exist in a higher dimensional space that we can't directly observe. Our entire universe, past, present, and future, might be just one kernel's worth of expansion in an endless cosmic popping process. What makes this particularly fascinating is that each bubble universe might have different properties. The fundamental constants of physics, things like the strength of gravity, the mass of electrons, or the speed of light might vary from one universe to another. Some universes might have stronger gravity that causes them to collapse quickly. Others might have weaker gravity that prevents stars and galaxies from forming. Some might have different numbers of spatial dimensions, or time that flows differently, or entirely different particles and forces. Our universe, with its particular set of physical laws that allow for the formation of atoms, stars, planets, and eventually life and consciousness, might be just one possibility among infinite variations. We exist in this particular bubble, not because it's special in any cosmic sense, but simply because it happens to have the right conditions for our kind of existence to emerge. This creates a humbling perspective. All of human history, every thought that's ever been thought, every discovery that's ever been thought, every discovery that's ever been made, every work of art that's ever been created, all of it might be confined to just one soap bubble in an infinite cosmic bath. Yet there's something beautiful about this smallness. It suggests that our bubble, however tiny in the grand scheme of things, is complete and perfect in its own way. A complete cosmic story unfolding in its own space and time. And if the multiverse is real, then right now as you read these words, countless other bubble universes might be forming, expanding, evolving, perhaps even giving rise to their own forms of consciousness that contemplate their own cosmic boundaries and wonder what lies beyond their own cosmic horizons. In our universe, when you drop an apple, it falls down toward the earth. This seems so natural, so inevitable, that it's hard to imagine it being any other way. But what if, in another bubble universe, floating somewhere in the cosmic bath, apples fell upward or sideways? Or what if they didn't fall at all, but instead sprouted wings and flew away? The multiverse suggests that the laws of physics we take for granted might be just one set of rules among countless possible sets, each governing its own separate reality. This isn't merely playful speculation. The fundamental constants and laws that govern our universe appear to be finely tuned for the existence of complexity, life, and consciousness. The mass of the proton, the strength of the electromagnetic force, the rate of cosmic expansion, all of these seem to fall within narrow ranges that allow atoms to form, stars to shine, and planets to remain stable long enough for evolution to work its slow magic. But why these particular values? Why not others? The multiverse offers an intriguing answer. Perhaps every possible set of values is realized somewhere. In this view, we exist in a universe with our particular physical laws, not because they're the only possible laws, but because they're the only laws that permit our kind of existence. It's a cosmic selection effect. We observe a life-friendly universe because we couldn't exist in any other kind. Imagine universes where the electromagnetic force is much stronger than in our reality. In such universes, atoms might be too tightly bound for complex chemistry to occur. You couldn't have the delicate molecular dance that creates proteins, DNA, or the countless other organic molecules that make life possible. These universes might be filled with simple inert matter, hydrogen and helium, that never coalesce into anything more interesting. Or picture universes where gravity is much weaker than in our cosmos. Stars might never form because gas clouds couldn't collapse under their own weight. Without stars, there would be no nuclear fusion to create heavy elements, no supernovas to scatter those elements through space, no raw materials for rocky planets or the chemistry of life. These universes might remain forever dark and cold, filled with thin gas that never condenses into anything substantial. Even stranger possibilities emerge when we consider universes with different numbers of dimensions. Our reality has 3 dimensions of space and 1 of time, but mathematics suggests other combinations are possible. What would it be like to exist in a universe with only 2 spatial dimensions, where everything is essentially flat? Or in a universe with 4 spatial dimensions, where the familiar inverse square law of gravity becomes an inverse cube law, making stable planetary orbits impossible? Some bubble universes might have time that flows differently, perhaps running backward, or splitting into multiple streams, or flowing at different rates in different regions. Others might have space that's fundamentally discrete rather than continuous, like a cosmic computer made of pixels rather than smooth geometry. The most radical possibilities involve universes with entirely different particles and forces. While our universe has electrons, protons, neutrons, and the four fundamental forces, other universes might be built from completely different building blocks. There might be realities where consciousness emerges from patterns in exotic matter. Yet for all their strangeness, these alternate realities would be complete universes in their own right. If conscious beings could somehow exist in them, they would find their own laws of physics just as natural and inevitable as we find ours. They might look out at their own cosmic horizons and wonder about the nature of existence, never suspecting that their reality is just one variation among infinite others. This perspective transforms our understanding of what it means for something to be natural or fundamental. The laws of physics that seem so basic to us, conservation of energy, the speed of light, the structure of atoms, might be local bylaws rather than universal principles. They govern our cosmic neighborhood but might have no authority in other regions of the greater multiverse. In a cosmos of infinite variety, every possible reality gets its chance to exist, to evolve, to explore the implications of its own particular set of rules. Our universe, with its galaxies and stars, and the quiet planet where you're reading these words, is one beautiful note in an infinite cosmic symphony. If other universes exist alongside our own, what separates them? What prevents us from simply stepping from one cosmic bubble into another, like walking between rooms in an enormous house? The barriers between universes, if they exist at all, must be unlike any boundary we can easily imagine. Not walls made of matter, not force fields, powered by energy, but something far more fundamental and strange. The most natural barrier between bubble universes might be space itself, or rather, the lack of space between them. In our everyday experience, we think of space as a neutral backdrop against which things happen, an empty stage where matter and energy perform their cosmic dance. But Einstein taught us that space is something, not nothing. If each universe is a bubble of space-time created by its own inflationary Big Bang, then the space inside each bubble might be entirely self-contained. There might be no external space for these bubbles to float in, no cosmic bathtub containing them all. Each universe would be complete in itself, with its own interior space, but no necessary connection to any external space that might contain other universes. Think of it this way. Imagine you're reading a novel, and you wonder what lies beyond the edges of the story. You might imagine the characters stepping outside the plot and meeting characters from other novels. But novels don't actually exist in some larger literary space where their characters could mingle. Each story is complete in itself, existing in its own narrative dimension, without any need for external space to contain it. Similarly, each universe might be complete in its own space-time, with no need for a larger space to contain all universes. The barrier between universes wouldn't be a physical wall, but rather the simple fact that each universe's space is entirely its own, with no overlap or connection to other spaces. But some theories suggest more exotic possibilities for inter-universal barriers. In certain models of the multiverse, different universes might exist in higher dimensional spaces that we can't directly perceive. Just as a two-dimensional being living on the surface of a sphere might be unaware of the three-dimensional space around them, we might be unaware of higher dimensions in which other universes exist. In such scenarios, the barriers between universes might be measured not in miles or light years, but in directions we can't point to or even imagine. Other universes might be infinitesimally close to us, in these higher dimensions, closer than the width of an atom, lie yet remain completely inaccessible because we can't move in those dimensions. In such scenarios, the barriers between universes might be measured not in miles or light years, but in directions we can't point to or even imagine. Even stranger possibilities emerge from quantum mechanics, which suggests that reality might be fundamentally probabilistic rather than deterministic. Some interpretations of quantum theory propose that every quantum event causes the universe to split into multiple branches, each exploring a different possible outcome. In this view, the barriers between universes aren't spatial but probabilistic minast. Each universe represents a different path through the branching tree of quantum possibilities. These quantum barriers would be absolute in a way that's hard to imagine. You couldn't cross from one branch of reality to another any more than you could change the past. Each universe would contain observers who remember one particular sequence of quantum outcomes, while other universes contain observers who remember different sequences. The barriers between these realities would be woven into the very fabric of causality itself. Perhaps the most profound barrier between universes is consciousness itself. If other universes exist but contain no conscious observers, do they exist in any meaningful sense? And if they do contain consciousness, but that consciousness is so different from ours that we couldn't recognize it as such, would communication be possible even if the spatial barriers could somehow be overcome? There might be universes where consciousness emerges from patterns in space itself rather than from matter, where thoughts move at the speed of light across galactic distances, where individual minds span entire stellar systems. The gulf between such forms of consciousness and our own might be unbridgeable, not because of physical barriers, but because of the fundamental incompatibility of different ways of being aware. Yet perhaps the most beautiful thing about these barriers is that they preserve the integrity and completeness of each universe. If realities could easily bleed into one another, each would lose something essential about its own character. The barriers between universes ensure that each cosmic story can unfold in its own way, complete and perfect within its own boundaries.
E. E.
There comes a moment in every deep conversation about the cosmos when we must pause and acknowledge something both humbling and beautiful. We are exploring these vast questions with minds that evolved to hunt and gather on an African savanna, using mathematics that began with counting sheep and measuring fields, guided by instruments that, however sophisticated, are still fundamentally limited by the same physical laws that govern the very phenomena we're trying to understand. Consider the elegant irony of our situation. We're using light to study the boundary of the observable universe, but that boundary exists precisely because light can only travel so fast, and the universe has only existed for so long. It's like trying to measure the size of a room using a ruler that can only extend to the middle of the floor. The tool that allows us to explore also defines the limits of our exploration. Our most powerful telescopes can peer across billions of light-years of space and billions of years of time, revealing galaxies in their cosmic infancy and mapping the distribution of matter on the largest scales imaginable. Yet these same instruments are fundamentally constrained by the horizon of observability. No telescope, no matter how advanced, can see beyond the cosmic microwave background because there's no light from earlier times to detect. The universe itself prevents us from looking any deeper into its past. Even more fundamentally, we're trying to understand concepts that stretch far beyond our evolutionary experience. Our brains developed pattern recognition and spatial reasoning to help us navigate environments measured in kilometers, not cosmic distances measured in billions of light years. We evolved to think about objects that last minutes to decades, not cosmic processes that unfold over eons. Is it any wonder that infinity feels impossible to grasp, or that the absence of an edge seems incomprehensible? Mathematics has carried us far beyond our biological limitations, allowing us to describe and predict phenomena that we could never directly experience. The equations of general relativity let us map the curvature of space-time, even though we can barely imagine what four-dimensional curvature means. Quantum mechanics gives us precise predictions about the behavior of particles, even though quantum superposition defies every intuition we have about how objects should behave. But mathematics itself might be reaching its limits when applied to questions about cosmic boundaries. The mathematical concept of infinity is precise and well-defined, but does it correspond to any physical reality? Can we ever know whether space is truly infinite, or whether the multiverse contains infinitely many universes? These might be questions that mathematics can pose but not answer. Our scientific instruments, marvelous as they are, face similar limitations. We can detect gravitational waves from colliding black holes billions of light years away. We can measure the cosmic microwave background radiation with exquisite precision. We can map dark matter through its gravitational effects, even though we've never detected a dark matter particle directly. Yet all of these achievements still leave us confined to our observable cosmic bubble, unable to probe beyond the fundamental horizons built into the structure of space-time itself. Perhaps most poignantly, we're using human language to discuss concepts that might be fundamentally beyond linguistic expression. Words like edge, beyond, outside, and infinite carry meanings shaped by our everyday experience with finite objects in familiar spaces. When we try to apply these words to the universe as a whole, we might be like someone trying to describe color to a person who has never seen, or trying to explain music to someone who has never heard sound. The cosmic boundary question pushes us to the very limits of human understanding, not just the current limits, but perhaps the fundamental limits of what minds like ours can comprehend. We are finite beings, trying to understand potentially infinite realities, temporal creatures, trying to grasp eternity, three-dimensional thinkers, trying to visualize higher dimensional spaces. Yet, there's something magnificent about our persistence in pushing against these boundaries. Even if we can never fully answer the question of what lies beyond the edge of everything, the fact that we can ask the question at all represents something remarkable about consciousness and curiosity. We are the universe's way of wondering about itself, even when minor psi, perhaps especially when minor psi, the wondering leads us to the edges of comprehension. In acknowledging the limits of our tools and minds, we don't diminish the value of our cosmic quest. Instead, we recognize it for what it truly is, an act of profound courage and creativity, a reaching toward mystery that defines us as conscious beings in a vast and wonderful cosmos. There's a special kind of question that has haunted human minds since we first looked up at the night sky and wondered. These are the questions that seem perfectly reasonable to ask, that feel like they should have answers, yet remain beautifully, persistently mysterious, no matter how much we learn. The question of what lies beyond the edge of the universe is one of these minutes, a question that might be fundamentally unanswerable, not because we lack clever enough minds or powerful enough instruments, but because the question itself might be pointing towards something beyond the reach of any possible answer. This might sound frustrating, like cosmic injustice. Why should the universe dangle tantalizing mysteries in front of us if it never intends to resolve them? But there's another way to think about unanswerable questions. They might be gifts rather than frustrations, invitations to a kind of wonder that answerable questions can never provide. Consider how different it feels to contemplate a solved mystery versus an unsolved one. When you understand exactly how a magic trick works, it loses its ability to amaze you. The mechanics become clear, the wonder evaporates, and you're left with mere technique. The pur in double wonder evaporates, and you're left with mere technique. But the magic tricks that truly captivate us are the ones that remain mysterious even after multiple viewings, that continue to surprise and delight precisely because we can't reduce them to simple explanations. The cosmic boundary question might be the ultimate magic trick, not because the universe is trying to deceive us, but because some realities might be too large, too fundamental, too strange to fit within the frameworks that minds like ours use to understand things. The question of what's beyond everything might be like asking what's north of north, or what happened before time began, or what the color blue tastes like. Grammatically correct, but pointing toward conceptual territories that our usual ways of thinking simply can't navigate. Yet, these unanswerable questions serve crucial purposes in human experience. They remind us that mystery is not the enemy of knowledge, but its companion. Every answer we discover opens up new questions, deeper puzzles, more subtle mysteries. If we could answer every question definitively, we might find ourselves in a strangely impoverished universe, one where curiosity had nowhere left to go, where wonder had been exhausted by explanation. The cosmic boundary question keeps alive a particular kind of intellectual humility. It reminds us that however much we learn about galaxies and quantum mechanics and the curvature of space-time, we remain small beings in a vast cosmos that may contain infinities we can barely imagine. This humility isn't a weakness, it's a source of strength that keeps us curious, keeps us asking questions, keeps us growing. There's also something deeply human about our relationship with unanswerable questions. They connect us to every generation of humans who have looked up at the stars and wondered about boundaries and infinities. The same questions that puzzled ancient philosophers puzzle us today, creating a thread of continuity across centuries and cultures. When you wonder about the edge of everything, you're participating in a conversation that began around the first campfires and will likely continue for as long as conscious beings exist. Some of the most profound human experiences emerge from contemplating unanswerable questions. The feeling of standing under a clear night sky and sensing the vastness that surrounds us. The vertigo that comes from trying to imagine infinity. The peaceful awe that settles over us when we realize how much we don't know. These experiences shape us in ways that definitive answers never could. Perhaps the real value of the cosmic boundary question isn't in any answer we might eventually find, but in how the question changes us. Contemplating the possible edge of everything, or its absence, stretches our minds in directions they don't normally go. It invites us to think beyond our usual categories, to imagine possibilities we can barely conceive, to sit comfortably with uncertainty and mystery. In a sense, unanswerable questions are like cosmic koans puzzles, designed not to be solved, but to transform the questioner. They take us beyond the realm of facts and explanations into the realm of wonder and contemplation. They remind us that some of the most important aspects of existence might not be answerable, but experiential, not solvable, but livable. Tonight, as you drift towards sleep, perhaps you can find peace in the beauty of not knowing, in the gift of questions that will outlive any answers we might discover. When Albert Einstein was a young boy, he imagined himself riding alongside a beam of light, wondering what the universe would look like from the perspective of a photon traveling at the speed of light. This act of imagination, more part playful, part serious, entirely human, eventually led to the theory of relativity and revolutionized our understanding of space, time, and gravity. It reminds us that some of our greatest scientific breakthroughs begin not with equations or experiments, but with the simple human act of imagining what might be possible. At the frontiers of cosmic understanding, imagination becomes not just helpful, but essential. We can't visit the edge of the observable universe, can't step outside our cosmic bubble to see what might lie beyond it, can't conduct experiments on infinity itself. Instead, we must use that remarkable human faculty that allows us to picture things we've never seen, to explore possibilities that might never be directly observable, to think thoughts that stretch beyond the boundaries of immediate experience. But imagination in science isn't mere fantasy or its disciplined dreaming. Creativity constrained by logic and guided by what we already know to be true. When cosmologists imagine parallel universes with different physical laws, they're not just spinning stories, they're following mathematical threads that emerge from our best theories about how reality works. When they picture space that curves back on itself or extends infinitely in all directions, they're translating precise mathematical descriptions into forms that human minds can begin to grasp. The challenge is that the cosmic boundary question pushes imagination to its very limits. How do you picture infinity? How do you visualize space with no edges? How do you imagine beyond, when beyond might be a meaningless concept? It's like trying to imagine a new primary color, or trying to conceive of a direction that's perpendicular to up, down, north, south, east, and west. The concepts strain against the very structure of human thought. Yet this is precisely where imagination proves its worth. Even when we can't fully grasp a concept, imagination allows us to approach it, to circle around it, to catch glimpses of its edges and shadows. We may never be able to truly visualize four-dimensional space, but we can imagine what it might be like to live in such a space, what kinds of objects might exist there, how movement and distance might work differently than in our familiar three dimensions. Imagination also allows us to explore the emotional and philosophical implications of cosmic possibilities. What would it feel like to know that you exist in an infinite universe filled with infinite copies of yourself? How would it change your sense of identity and purpose? What would it mean for human meaning and value if our entire observable cosmos were just one bubble among countless others in an infinite multiverse? These questions don't have scientific answers in the usual sense. You can't design an experiment to measure the psychological impact of cosmic infinity, but imagination allows us to explore them nonetheless, to inhabit these possibilities emotionally and intellectually, even if we can't observe them directly. Perhaps most importantly, imagination keeps us humble about the boundaries of current knowledge, while simultaneously pushing us to expand those boundaries. When we imagine what might lie beyond our current understanding, we create space for new discoveries, new theories, new ways of thinking about reality. Every scientific revolution began with someone imagining that things might be different than they seemed, that there might be more to reality than meets the eye. The cosmic boundary question exemplifies this dual role of imagination. On one hand, it reminds us that there might be aspects of reality that forever remain beyond human comprehension, not because we're not clever enough, but because some realities might be too large or too strange for minds like ours to fully contain. On the other hand, it challenges us to keep pushing against those limitations, to keep imagining new possibilities, to keep asking questions that stretch our understanding in new directions. In contemplating the possible edge of everything, we're doing something quintessentially human, using our gift of imagination to reach toward mysteries that may be larger than ourselves. Whether those mysteries ever yield definitive answers matters less than the fact that we continue to reach, continue to wonder, continue to imagine what might be possible in a cosmos vast enough to contain both our questions and whatever realities lie beyond our ability to question them. Here you are, lying somewhere on a small rocky planet, reading about the possible edges of everything, while that planet spins on its axis and orbits a middle-aged star that's one of hundreds of billions in a galaxy, that's one of hundreds of billions in an observable universe that might be just a tiny fragment of something infinitely larger. When you put it that way, it might seem like you barely exist at all, a fleeting arrangement of atoms that happen to become conscious for a brief cosmic moment in an overwhelmingly vast and possibly endless cosmos. Yet there's another way to think about your place in this vastness, one that doesn't diminish you, but rather illuminates something magnificent about what it means to be human. You are not separate from the universe looking in at it. You are the universe becoming aware of itself. Every atom in your body was forged in the nuclear furnaces of ancient stars. Every element in your DNA was scattered across space by stellar explosions. Every breath you take connects you to the atmosphere of a planet that formed from cosmic dust billions of years ago. When you contemplate the possible edge of everything, you are engaging in one of the most remarkable phenomena the universe has yet produced: consciousness contemplating its own nature and boundaries. Out of hydrogen and helium, gravity and time, the cosmos has somehow arranged itself into forms complex enough to look back at their origins and wonder about their ultimate context. You are not a tiny accident in a vast machine. You are perhaps the most extraordinary thing the universe has yet accomplished. The questions we've been exploring together tonight, about boundaries and infinities, about what might lie beyond the edge of everything, these aren't abstract puzzles with no bearing on daily life. They're intimately connected to how we understand our purpose, our relationships, our responsibilities to each other, and to the small planet we share. If the universe is infinite, containing infinite copies of every possible arrangement of matter, does that make your choices meaningless? Or does it make them infinitely meaningful, echoing forever through endless variations of reality? If our entire cosmos is just one bubble in an infinite multiverse, does that diminish the importance of human love, creativity, and kindness? Or does it suggest that these qualities are so fundamental to existence that they emerge wherever consciousness is possible? Consider the remarkable fact that you can feel wonder, awe, in a universe that might be infinite and possibly filled with infinite forms of complexity. The capacity for awe and curiosity stands out as something precious. The feeling you have when you look up at the night sky and sense the vastness beyond, the gentle vertigo that comes from trying to imagine infinity, the peace that settles over you when you realize how much mystery remains. These experiences connect you to something larger than yourself, while simultaneously affirming your unique perspective within that larger whole. Your small life, bounded by a few decades of time and a few thousand miles of familiar geography, becomes a lens through which the infinite universe can examine itself. Through your eyes, the cosmos sees the patterns of stars and the dance of galaxies. Through your mind, existence contemplates its own nature and wonders about its own boundaries. Through your capacity for love and creativity, the universe expresses something that might not exist anywhere else, in any other form. This perspective transforms the cosmic boundary question from a source of existential anxiety into a source of existential comfort. Whether the universe has edges or extends forever, whether we live in one cosmos or countless cosmoses, whether infinity is real or just a mathematical abstraction, these questions matter not because they determine the value of human experience, but because they provide a context vast enough to match the depth of human wonder. You don't need to solve the mystery of cosmic boundaries to live meaningfully within them. Your relationships with other people, your moments of joy and creativity, your acts of kindness and courage, these have value, not because of their cosmic significance, but because of their immediate, lived reality. The universe is large enough to contain both infinite mystery and finite meaning, vast enough to encompass both endless questions and personal answers. Tonight, as you consider drifting towards sleep, remember that you carry within yourself the same elements that shine in distant stars, the same forces that shape galaxies, the same mystery that pervades the cosmic horizon itself. There's a special kind of peace that comes from accepting that some questions don't need answers, at least not the kind of final, definitive answers we sometimes think we want. As we've wandered together through cosmological possibilities tonight, exploring edges that might not exist and infinities that might be real, perhaps you've discovered something that many people find surprising. Not knowing can be more comfortable than knowing. Mystery can be more satisfying than certainty. Consider how different your relationship with the night sky would be if we had mapped every star, catalogued every planet, and answered every question about cosmic boundaries and ultimate origins. The stars would still be beautiful, but would they still be wonderful? Would you still feel that gentle pull of curiosity when you looked up at them? Or would they become merely familiar objects in a completely understood cosmos? There's something essential about mystery that feeds the human soul in ways that answers, however elegant, cannot. Mystery invites participation in a way that solved puzzles never can. When you look up at the night sky and wonder about what lies beyond the cosmic horizon, you're not just thinking about astronomy, you're engaging in an act of imagination, wonder, and humility that connects you to the deepest currents of human experience. The cosmic boundary question, whether it has an answer or not, serves as a gateway to this larger relationship with mystery. It reminds us that we live in a reality vast and strange enough to contain questions that might be unanswerable, concepts that might be unthinkable, possibilities that might stretch beyond the reach of any finite mind. This isn't a failure of human intelligence. It's a testament to the richness of existence itself. Think about the alternative for a moment. Imagine a universe small enough and simple enough that human minds could eventually understand it completely, where every question could be answered definitively, where no mystery remained unsolved. Such a universe might feel safe and comprehensible, but it would also be profoundly claustrophobic. There would be nowhere left for wonder to go, no frontiers left for curiosity to explore, no unknown territories to inspire the kinds of thoughts and feelings that make us most deeply human. Mystery preserves something essential about the human experience: our capacity for growth, our openness to surprise, our willingness to be changed by encounters with the unknown. When we acknowledge that we might never know what lies beyond the edge of everything, we're not admitting defeat. We're preserving space for the kinds of experiences that keep life interesting and meaningful. The comfort of mystery also lies in its democratic nature. Unlike specialized knowledge that requires years of study to access, cosmic wonder is available to anyone who takes the time to look up and think deeply. A child asking what's past the end of space, Windibles and Tyr, of Mr. Paul's and the end of space, is engaging with the same fundamental mystery that occupies professional cosmologists. The question belongs to all of us, and so does the wonder it inspires. There's also something deeply honest about embracing mystery. It acknowledges the real limitations of human knowledge, while simultaneously celebrating the remarkable fact that we can push against those limitations at all. We are beings who can conceive of infinity, even if we can't fully grasp it, who can ask about the edge of everything, even if the question might be unanswerable, who can feel awe at scales that dwarf our immediate experience. Perhaps most importantly, mystery teaches us a valuable form of intellectual humility. In our daily lives, we often feel pressure to have opinions about everything, to take definitive positions, to speak with confidence even about matters we don't fully understand. The cosmic boundary question offers a refreshing alternative. The possibility of saying, "I don't know," not as a confession of ignorance, but as an acknowledgement of reality's genuine complexity. This kind of humility can be profoundly relaxing. It releases us from the exhausting task of having to understand everything, while simultaneously opening us to the possibility of being surprised, amazed, and transformed by whatever we might discover. When we accept that some aspects of reality might be too large or too strange for us to fully comprehend, we create space for wonder, awe, and a kind of cosmic contentment that comes from knowing our place in a universe vast enough to contain infinities we can barely imagine. As you prepare for sleep, perhaps you can find comfort in not needing to solve the riddle of cosmic boundaries, in being held gently by mysteries larger than any answer you could contain. We are explorers by nature, we humans. From the first curious ancestor who wondered what lay beyond the next hill, to the children today who ask where the universe comes from, we have always been driven by an irrepressible desire to know what lies beyond our current horizons. The question of cosmic boundaries sits at the culmination of this ancient human impulse, the ultimate expression of our species-wide project of exploration and discovery. What strikes me as particularly beautiful about this cosmic quest is how it connects us across time and culture. The ancient Greeks, who first proposed that the Earth was round, the medieval scholars who debated whether space could be infinite, the Renaissance astronomers who discovered that our sun was just one star among countless others, the modern cosmologists mapping the cosmic microwave background, all are part of the same grand human conversation about the nature and extent of reality. You, lying there tonight, contemplating these questions, are the latest participant in this ancient dialogue. When you wonder about the edge of everything, you're not just satisfying idle curiosity, you're carrying forward a torch that has been passed from generation to generation, each one pushing a little further into the unknown, each one asking questions that stretch the boundaries of human understanding. This continuity of wonder suggests something profound about human nature. Despite all our technological advances, despite our modern sophistication and scientific knowledge, we remain fundamentally driven by the same curiosity that motivated our earliest ancestors. We still look up at the night sky and feel something stir within us, a mixture of awe and longing and questions that we can't quite articulate, but somehow know are important. This know are important. The cosmic boundary question also reveals something remarkable about human creativity and imagination. Faced with mysteries that might be literally unimaginable, we keep trying to imagine them anyway. We invent new mathematics to describe curved space-time, develop new metaphors to help us think about infinity, create new instruments to peer deeper into space and time. Even when we reach the apparent limits of what's knowable, we keep pushing against those limits with remarkable ingenuity and persistence. Consider how far we've already come in this cosmic journey. A few centuries ago, the entire known universe consisted of the Earth, Sun, Moon, planets, and stars that appeared to be fixed to a celestial sphere. Today, we know about galaxies billions of light years away, dark matter and dark energy, the cosmic microwave background radiation, and the possibility that our observable universe might be just a tiny fragment of something vastly larger. Each generation has expanded the horizon of the known, often in ways that would have been completely unimaginable to their predecessors. Yet, with each expansion of knowledge, new mysteries emerge. The cosmic boundary question itself couldn't have been asked in its current form until we understood concepts like the Big Bang, cosmic expansion, and the speed of light as a universal limit. Our growing knowledge doesn't eliminate mystery. It reveals new kinds of mystery, deeper puzzles, more sophisticated questions. This suggests that the human journey of cosmic exploration is far from over. Future generations will almost certainly discover things about the universe that we can't even imagine today. They might develop new ways of thinking about space and time, new technologies for exploring cosmic boundaries, new mathematical frameworks for understanding infinity and existence. They might even find ways to answer questions that seem unanswerable to us. But I suspect they will also discover new questions to replace the ones they solve, new horizons to explore beyond the ones they reach, new mysteries to contemplate at the edges of their expanded understanding. The cosmic quest doesn't end when we answer our current questions. It evolves, deepens, and continues in forms we can't yet anticipate. What remains constant is the human capacity for wonder itself. No matter how much we learn about the universe, no matter how far our understanding expands, there will always be something in human consciousness that responds to mystery with curiosity, to vastness with awe, to the unknown with a desire to explore. This capacity is perhaps our most precious inheritance and our greatest gift to future generations. Tonight, as you drift towards sleep, you're not just contemplating cosmic boundaries, you're participating in the ongoing human adventure of trying to understand our place in the vast mystery of existence. You are both heir to thousands of generations of cosmic questioners and ancestor to thousands more, who will carry the torch of wonder forward into futures we can barely imagine. And so we reach the gentle end of our cosmic journey together, having wandered from sandbox edges to infinite possibilities, from observable horizons to unimaginable multiverses. Perhaps, in contemplating these vast mysteries, your sense of what it means to exist has shifted slightly, like stars appearing as your eyes adjust to darkness. We've discovered that the question of cosmic boundaries leads us not to simple answers, but to deeper wonder, not to final destinations, but to new territories of amazement. I'm curious, are you still awake out there, or has the vastness of infinity finally carried you towards sleep? If you're somehow still conscious after all this cosmic wandering, I admire your dedication to mystery. You might just be cut out for this universe we find ourselves in. Here's a simple question before we part. Do you think you'll look at the night sky differently now? If this gentle exploration has resonated with you, please consider giving it a like or subscribing. These small gestures help our quiet conversations about cosmic mysteries reach other wondering souls who might need them. Let the algorithm know that sometimes the most important questions are the ones that don't demand urgent answers. May you rest peacefully in the embrace of infinite mystery, knowing that you are both wonderfully small in the vastness and magnificently important as a point where the universe becomes aware of itself.